Hello friends, today we are starting with SYBSc Physics semester 3. Our subject code is PHY 241 MN, that is minor applied physics 1. This subject is for 2 credits and having 30 lectures. I am Dr. Anil Gite from Department of Physics. So today we start with the second module. Its name is laser and its applications. This is the course content for this module: introduction to laser, principle of laser action, Einstein's coefficient in the laser action, different characteristics of laser light, population inversion, some components of lasers, types of laser and laser applications in daily life. So, first of all we start with the acronym laser. This laser stands for, each word L stands for light, A stands for amplification, S stands for stimulated, E stands for emission and R stands for radiation. So, full term this laser is nothing but light amplification by stimulated emission of radiation. Means there is one process which is stimulated emission by which light amplification takes place, and this is nothing but laser light. Okay. So, in laser light, actually what is this laser light? When we say the laser light, in the laser light there is optical radiations which are taking place in the stimulating electrons or ions or molecules, and they transit the atoms from lower energy state to higher energy state. There are various modes of the laser, but mainly we are using for our syllabus in single mode system of laser. Light emission of lasers having the low divergence, it is around 5 to 10 degrees, and this laser light requires more complex circuitry as compared to ordinary LED lights. Laser action occurs basically with the help of 3 main processes. The first process is absorption process, second is spontaneous emission process, and third one is stimulated emission process. So, one by one we will see these 3 processes in the laser action. So, first of all we go for the properties of laser. Basically, as compared to ordinary light, laser light is quite different. The laser light possesses these properties. First property is laser light is highly monochromatic in nature. Mono means single and chromatic means color, means we can say that the laser light having single color, that is range of wavelength is very specific in nature, that is why color is single. Second main important property of laser is that the laser beam is highly coherent in nature. Coherent means whatever the photons which are produced by the laser light, they are having constant phase, or the phase between these photons is constant with time and phase. And third property is that the laser light is directional in nature, that is very tight beam of this laser having very strong concentration at the particular point. So, directionality is very high as compared to the ordinary light. So, ordinary light is not monochromatic, not coherent and not directional in nature, but laser light possesses these properties. That is why the laser light differs as compared to the ordinary light. So, to produce this laser light, basically we have to see these processes which are involved in the laser action. First process is absorption process, second is spontaneous emission process, third one is stimulated emission process, and last one is population inversion. So, first of all we will go with the first process, which is absorption process. In ordinary case, what happens that in the material, the atoms are situated in the different energy levels according to their energies. So, for generalization we have shown 2 energy levels over here, that is E1 which is at the bottom and E2 which is at the top. Between these 2 energy levels, when we incident the external photon, that photon is absorbed the atoms at the lower energy level. The lower energy level, which we will call it as a ground state, that is E1 state, and the atoms present in the lower energy state takes this external photon and moves to the higher energy state, that is excited state, E2 state. The process is nothing but absorption process, that is when the external photon is incident on the ground state, it absorbs the atoms in the ground state, absorbs that photon and moves to the excited state. This process is nothing but absorption process. Generally this process is occurring at the room temperature, normal temperature, since the number of atoms in the E1 state are greater as compared to the number of atoms in the E2 state, that is in the excited state. So, in the spontaneous emission what happens? Suppose the absorption is occurred and atom is already moved to the higher energy state, that is E2 state. In the E2 state, the lifetime of that atom is very small, that is about the lifetime of an hydrogen atom, about 10 raised to minus 8 seconds. So, the atom does not stay for a longer time in the excited state, that is in the E2 state, and it tries to come to the lower energy state, that is it try to occupy the lower energy state, that is E1 state. That is why when it comes from the higher energy state E2 to lower energy state E1, it randomly emits the photon in any direction, and this random emission of photon gives the light. That light is a spontaneous emission. So, the ordinary light is produced with the help of only this process, which is the spontaneous emission. So, atom will decay from the higher energy level to lower energy level by the emission of photon from higher energy level to lower energy level, and this emission is random process, is nothing but the spontaneous emission. But the third process, that is stimulated emission process. In the stimulated emission process, what happens that atom which is in the excited state, that is in E2 state, waits for the sufficiently longer time. So, word wait is very important, that is the lifetime of an atom in the E2 state is sufficiently large, so that the external photon can stimulate to the atom in the excited state itself. So, that external photon will stimulate the atom which is present in the excited state, and that external photon will force the atom to come to the ground state. So, the external photon and incoming photon both are produced when atoms come from higher energy level to lower energy level. So, one photon which is stimulating photon and one photon which is due to the excess energy from E2 to E1, that two photons are emitted, that gives two photons which are coherent, monochromatic and directional in nature. So, this light which is produced by the process of stimulated emission is the laser light, which is possessing all the characteristics of laser light, that is monochromatic, directional and coherent in nature. So, when we go for the stimulated emission, these stimulated emission has a unique properties, that is the phase with the incident photon, that is coherent in nature, same wavelength we can say that the monochromatic in nature, and travel in same direction we can say that it is highly directional in nature. So, the stimulated emission is the process which gives the laser radiations. So, here to produce the to understand the operation of laser light, we have shown the laser cavity. In the laser cavity, what you can say that in the first diagram you are having the tube like structure. In the tube like structure you can see that there are electrons in the inside the tube. They are randomly moving in the tube, that is that tube we are calling at a laser cavity. These laser cavity produces the photon which can be shown in the second figure. In the second figure, the laser photons which are coming in forward and backward direction in the laser cavity, they are coming out of the one side of the tube, and that is giving you the laser light. We can say that it has all the photons which are coming out, they are having same frequency, same phase, and they are coming in the same direction, that is in one directional. That is why this light is a laser light. So, in a laser, how actually laser works? In this diagram you can see that in the first diagram you can say that these two black lines which are nothing but the two sides of the laser. Within that two sides of laser you are having the rectangle stripe that shows the laser cavity, that is in between two mirrors the laser cavity is placed. So, what we are actually doing? We are pumping. Pumping is nothing but process of raising the atoms from the lower energy state, means ground state, to the higher energy state, means we have to supply the energy. So, on pumping, the atoms will move to the excited state. When atoms will move to the excited state, we say that after they are going to the excited state, their lifetime in the excited state is very small. That is why spontaneously they will emit the photon and they will come to the ground state, and that process is nothing but spontaneous emission. But in the third diagram, you can see that they will wait for a sufficiently longer time in the excited state, so that external stimulus is occurring on them in the excited state, and they will come to the lower energy state by giving the various photons out. That is, steady state laser operation takes place when there is occurrence of an stimulated emission. So, these are the three processes, that there is absorption process, there is spontaneous emission process, there is stimulated emission process, and in the steady state at stimulated emission we are getting the laser light. So, most important is that when we go for the condition of laser action or laser radiation, if you are having N1, N1 is nothing but number of atoms in the E1 state. E1 state is shown in the red color, that we can say that number of atoms at the ground state, that is at the lower energy state, and N2 is represent the number of atoms in the higher energy state, that is the excited state, that is E2 state. You can see in the diagram itself, E1 having sufficiently longer or large number of atoms, and E2 is only one atom is shown. That is in the normal case, in the equilibrium condition, that is at room temperature, the condition is that the number of atoms tries to reside at the ground state, at the lower energy state. So, N1 is greater than N2. So, radiation is mostly absorbed when you are having number of atoms at the ground state. That is, ground state atom will take the energy and then they will try to move to the excited state. So, in the spontaneous radiation dominates, means what happens when absorption occurs, the E1 atoms will reduce, that is number of atoms in the E1 state they will reduce, obviously they will move to the excited state. So, condition of population, that is number of atoms in E1 and E2 becomes reverse, that is N2 is very greater than N1. This process is very important, which we are calling as a population inversion. Population inversion is nothing but making the number of atoms in the excited state, that is E2 state, is large as compared to the number of atoms in E1 state. So, that condition is called as population inversion, that is N2 is very greater than N1. To make the population inversion, we have to do the process of pumping, that is raising the atoms from E1 state to E2 state. So, it is necessary for laser action to achieve the population inversion, that is to achieve the condition N2 very greater than N1. Right? So, at that time we have to go for the condition which is the stimulated emission and light amplification is taking place. So, at the bottom also written that it is necessary to achieve the population inversion, that is N2 very greater than N1 to achieve the population inversion. So, for laser action population inversion is necessary. So, it is written that what is population inversion? Population inversion is nothing but it is the process of producing population inversion. Population inversion means process of raising the atoms from or making the atoms in the excited state greater as compared to the lower energy. So, how to make the population inversion? We have to give the external source of energy, that is you can flash the light on the medium of laser, sufficient frequency, sufficient intensity light, or you can apply the external potential difference or electric discharge to the laser medium, so that atoms will move from ground state to excited state. So, these are the two examples we have written, that is flash lamp can be used to make the population inversion, and secondly electric discharge can be used to make the population inversion. So, to study the laser, we have Einstein's coefficient in laser action, that is all Einstein coefficients are related with only these three processes. There are three Einstein's coefficient. One is relating to the absorption, that is coefficient of absorption. Second is spontaneous emission, that is coefficient of spontaneous emission, that is A21, and third one is coefficient of stimulated emission, that is B21. So, one by one we will see these three coefficients only. What is absorption coefficient? Absorption coefficient is nothing but the coefficient which is related to the absorption of atom. We can say that rate of absorption. When atoms are moving from ground state to higher energy state, you can say that the rate of absorption, that is number of atoms which are taking the energy from external photon, that is the rate of absorption, will depend on the two parameters only. One parameter is how many number of atoms are present in the ground state, that is the rate of absorption is directly proportional to the number of atoms in the ground state, and secondly it also depends on the radiation density of the incident photon. So, rate of absorption depends on the number of atoms in the ground state and radiation density of incident photon, that is nothing but B12, that is 1 2 represents the atoms move from first, that is ground state, to the 2, that is excited state. So, second coefficient of absorption is spontaneous emission, that is coefficient A21. Already atoms are in the excited state for the spontaneous emission, and they will try to return to the ground state, that is E1 state, by their own. So, when they are coming from excited state to lower energy state, they are independent on the external photon, that is why they emit the light in any direction. So, the rate of spontaneous emission, I am talking about the rate of spontaneous emission, is only depend on the number of atoms which are present in the excited state. So, you can say that rate of spontaneous emission is proportional to the N2, that is number of atoms in the excited state. So, R spontaneous emission is equal to some constant, and that constant is A21, which is called as spontaneous emission coefficient of Einstein's coefficient of spontaneous emission. So, this process is independent on the external radiation, because atoms are coming their own from higher energy state to lower energy state. And last coefficient is stimulated emission, that is coefficient B21. In stimulated emission, what happens that atom will drop from higher energy state to lower energy state, but with the help of external photon, that is external photon will stimulate them. That is why we can say that rate of stimulated emission. When I talk about the rate of stimulated emission, that rate of stimulated emission will depend on obviously number of atoms present in the excited state, but with one more factor. Which is that one more factor? That is the atoms which are the radiations which are acting as a stimulus to the atom in the excited state. That is, rate of stimulated emission is directly proportional to the energy density of incident photon, and secondly it is proportional to the N2, that is number of atoms present in the excited state. So, R rate of stimulated emission is proportional to N2 and rho nu, which is density of incident photon, and when we remove this proportionality sign, we are getting the third coefficient, that is coefficient of stimulated emission. So, rate of spontaneous stimulated emission will depend on two things, that is number of atoms in excited state, and secondly energy density of incident photon on the excited state. So, these three basic coefficients are there, and we have the relation between them also. So, types of laser. They lasers depending on the active medium, we have solid state laser, liquid laser and semiconductor laser. So, according to that we have different types of laser, depends on active laser. So, applications of laser, there are different applications of laser. One is in scientific we go for the spectroscopy, that is study the atoms and molecules or different material substance. Then in laser ranging, then in photochemistry, laser cooling, nuclear fission. In military applications, we have different applications, that is defensive application, strategic defense initiative, laser sight, illuminator, range finder, target designator. These are the few applications of laser. Then in medical field, eye surgery, basically cosmetic surgery we use the laser. In industry and in commercial, in industry we are go for cutting, welding and making depending on the power of laser. In commercial CD player, DVD player we use the laser. In writer itself we are using the laser. Laser printer, printing laser is used. Laser pointers are there. Photolithography and laser light display. So, these are the classification generally given. Laser is classified according to the active medium, and secondly according to the output. According to output means which kind of laser light we are getting. If we are getting continuous laser light, we say that continuous wave laser. If we are getting pulses of laser, we say that it is pulse laser. And active medium means which medium you are using for the population inversion. If medium is solid medium, we say that it is solid state laser. If it is gas, we say that it is gaseous laser. If it is liquid, we say that it is liquid laser. If it is semiconductor, is semiconductor laser. So, depending on active medium and depending on the nature of output, lasers are classified into different groups. Okay. Thank you.